This goes back to 750 million years ago. Um, this is one theory of how the land masses were located, and we're going to follow them through the history. The colors basically mean where the lands end up. I mean, some of this yellow becomes North America. This purple becomes Indian subcontinent. Some of this yellow becomes Eurasia. And we've located Iran, which is this light blue here, and I'm going to try and follow this on the screen as we move along. It is important to know that we don't know at what time these lands were above sea level or below sea level. We know that they were formed, and you can see Iran is here, right near where Australia is. This is 450 million years ago. 410. .360. See, the lands are coming together. This is 300 million years ago. This is a period they call Pangea, when almost all the lands of the earth were connected, of course, except Iran. That's Eurasia taking form. This is Africa, Arabia, North America. So there's Iran. And Iran is going to touch Eurasia right around 200 million years ago, somewhere near where China is today. Now, this is the point where the Pangea starts to drift. You can see Africa separating, North America separating. Look, 130 million years ago, Iran becomes an island again. Eurasia is forming, North America, South America, Africa, India, South Pole. Let's keep going. 100 million years ago, you can see Africa coming up, India coming up. 50 million years ago, 30 million years ago. You can see now 20 million years ago, Iran is pretty much trapped between Eurasia, Africa, and India. This is 10 million years ago, and this is the present position. It is worth it to zoom in and look at Iran from 40 million years ago, near its current position. You can see maybe this is where Caspian Sea will become. It was probably a gulf. This is India, this is Africa and Saudi Arabia. 30 million years ago, 20 million years ago. Again, Caspian Sea was probably a gulf before Iran pinned it in. 10 million years ago, and one of the things to notice is how when these plates meet, we're going to have mountains. So where Eurasia meets India, Iran, and these islands that are forming what's called Europe today, we're going to have an orogeny, a range of mountains, Himalayas, the Hindu Kush, Alborz, the Caucasus, Urals, and all the way to Alps. This is one line of mountains. We're also going to have where Africa and Arabia meet Iran, we're going to have the Zagros range, and here another range of mountains to the east. This is very important formation of Iran, and we'll discuss this later. And this is Iran in its present position. The red line represents fault lines between plates, and this again is important because the issue of earthquake is going to come into question. This position from 10 million years ago is also very important because, as you can see, when these land masses collide, there's water getting trapped between them. That's why we have Lake Urumie, Caspian Sea, Aral Sea in the north, and I believe there must have been other lakes in the south. This is how they're going to get trapped. You see the water getting trapped there. we will talk about this. So when these three great plates surrounded the relatively smaller Iran, we had three mountain ranges, sort of like a triangle form, and the deserts we're talking about are the lowlands that were caught in the middle. Now, if you can see, the Eurasian plate is not going anywhere. The African and Arabian plate is moving northeast and counterclockwise. The Indian plate is moving northwest and clockwise. All this creates the kind of frictions that, created these mountains, but it also lifted the whole landmass of Iran high in elevation, together with the deserts. Everything was lifted up. When any two great plates meet, we get something called a subduction. That's the point where they collide. In Iran, we have three subduction zones along these three mountain ranges. When subduction happens, one of the plates, usually the bigger plate, slips under the smaller plates, in this case Iran, because Iran is smaller than the other three. And what happens is mountains start to form right where they collide, but also you start to get this pressure lifting the smaller plate, lifting it up. By the way, subduction zones are the cause of most earthquakes in Iran, but this is what happens. Let me show you more about subduction. The lithosphere layer of the mantle, the upper mantle, starts to slip under the other plate. It will create mountains, and of course the friction will create magma and heat and volcanoes. There are three types of subductions. The first one is oceanic convergence. This happens in the middle of the ocean. The other one is oceanic and continental convergence. And the one we're interested in is the continental convergence, which is what happened in the case of Iran. A good example of the type of subduction we're talking about is illustrated here. This is when the Indian plate is subducting and it's going under the Asian plate. And you can see when they start to meet 50 million years ago, the picture on top, they're more or less the same. But as the subduction occurs, not only we get huge mountains like the Himalayas, but notice how the Tibetan plate has been lifted and we got a Tibetan plateau. This is exactly what happened with Iran. That's why we have an Iranian plateau, because other plates are slipping under it and lifting it. Let's go back to our case, Iran, and consider how the creation of the mountains, the collision of the plates, and the lifting of the Iranian landmass to become a plateau might explain the characteristics of the land and even the existence of lakes in earlier times. We zoom into the central Iran, where the deserts are that we're looking at, and we wonder what if the whole landmass of Iran was under the surface of water before the collisions? So one day might rise out of the sea like they're doing now, like they do with any island when it's first formed. So, as they press against each other, we get more mountains, and the landmass starts to rise up also due to subduction. So now it's rising out of the water. It's a possibility, it's a far-fetched possibility, but this could explain how we end up with salt water in the middle of these lands. So once the mountains are completely formed, the subduction starts and start lifting the whole landmass up to make it a plateau. And as it's doing it, you can see there will be some areas that get closed off with the water in them. So this is how the old lakes in Iran had to be. This is like anywhere starting from 20 million years ago to certainly, the last mention of them is 4,200 years ago. They must have dried up all by then. So here's the plateau, just rising out of the water with these lakes. This is probably the form what we're proposing to return to put salt water back into these deserts where it evaporated. Again, this is a theory and I'm not sure about it. I'm certainly not sure about the extent of these seas. There might have been seas, but we don't know exactly how big they were.